Okay, we'll be very fast in going through this paper. So I've just picked some questions from past papers. Yeah, those ones which are not hard, but you need to know those questions that are very hard, like they need time. Those are the questions you come in an exam. Okay, so we'll go through some papers such as this one. All these questions, we'll go through them. All right. Okay, so this is the document I sent earlier on. So now what you are going to do is, this is you are writing on Friday, right? Okay. So the question is here. Okay. So now we have open bracket there. We have B set. Okay. This can be written as, it's more like subtraction, meaning that it is an intersection of something, right? Complement like that. Okay. Then union. All right. A complement like that, then there's complement outside there. So we can distribute this complement, then it will be what? So this will be B intersection, all right, A complement like that. Okay, so now this one will come here, and let me start with this one. This complement will come here, so it will be attached there. All right, then this union will change to intersection. Now the moment a complement crosses the union or intersection, it will change opposite. So this now it will be, this one will come there, which will have complement complement, which they will cancel, then we'll just remain with A like that. Okay, from there again I need to distribute this complement inside there. So this will be B, all right, complement. Then this has gone there, then we have intersection, which will change to union in this case. Then this A complement, then the complement will cancel, then we remain with this. All right, then from there what you're going to do here is see this condition which is inside there. All right, I can try to distribute. Let me do this. I can say I can now distribute inside distributive property. So I'll distribute this, what is inside there, then I'll have B complement, all right, intersection A, all right. Then this is the boundary, which is the union, open bracket. Then I have what? I have again A intersection A. I've just expanded by distributing using distributive property. All right. So we'll be able to know now that B, all right, B complement intersection A, all right, here, okay, A intersection A, they will still intersect at what? A. Okay. You see? So now what you're going to do here is, we'll say this guy here, they are meeting in A. No matter B complement, but they still meet in A. Remember, we have again the total A. So it will be good as us writing just the total A, because let's say we have this, right? And our B ranges from here, all right? Then our A, let's say, ranges from here. Okay, then the complement of B complement, okay, and also here we have B complement, then this is A down there. So where they intersect, yes, they intersect, but we'll still add A, which is union A. They will still be found in A both. So you just write A like that. Since they are subset, these ones, they are found in this one, so you just write A like that. Okay, so that is it about this one. Let's go to the next question. So the other question says, given the subset, now this is now application of what we are from doing. So we'll say, we'll make a line, all right? So this is our universal. So you choose the number. If you are not given universal set, you choose the number which are what? Big, and also the smallest. So the smallest I can see here is negative 5. So negative 5. Then I have the biggest number as what? 8. Okay, so set A has the number negative 2, so I can approximate to say this is my 0, all right? Then I won't show 0 if I want. Then I'll say for A, I have negative 2, so negative 2 be found somewhere there, all right? Then I have also negative 5, which is there. Then I have, with the positive, I have 3 and also 6. Even 1 negative is there, okay, in the set C. Then and 8 like that. So I have 3 positive and also 6 positive. Okay, so now I can say for A, I'll shade as negative 2. It will be crossed like that. Then 6, it will be open like that. So this is my A. Okay, so that's my A. Then what about my B? My B now will be negative 5, which is here. All right, it's not also closed. Then to what? To 3. So 3 is here. So I'll shade as well. This is my B. Then my C will be what? I have negative 1 there, which is closed. All right. So negative 1 there. This is our negative, right? No, this is, I need to have a negative. So my negative was supposed to be here, negative 1. This is 0. This should be 1. Yeah, let's pretend this is our 0, our 1. This is 1. Then let me light properly the number line. Okay. Okay, so we are saying this is our inverse. So we have 8 there as the largest, then we have negative 5. No, yeah, negative 5. Then followed by which number is negative? We have negative 2 and we have negative 1 there. Okay, meaning that we can have 0 if we want there. Then the positive one now they are ranging from 3. Okay, we have 3 there. Then we have 6 there. Okay, so these are enough. So now for A, I'll say negative 2 is here, right? Then to 6. Okay, so this is our A. Then our B is now negative. Our B is now negative. Our B is negative 5. So I'll come on negative 5 is not close, it's open bracket. So open interval to say. So this will be my B, then to 3. So it will end here. They are both open. So this is my B. Then my C will be negative 1, which will be closed. All right. Then to 8. 8 is also closed. Okay. So this is my C. So now how do I solve this one? Okay. They are saying we have A, okay, union, open bracket, B, complement, union, C, open bracket, complement. So we have A, union, open bracket. This one will be B, then this will be intersection C, complement, like that. Okay, so this is what we are going to simplify because it's simplified at this point. So what we need to do is I'll get this one then uniting with what? A. So it will be more like a subset if at all they will have spaces where they will intersect with this one. So we'll just include A values. Okay, range of A, because A is independent, then these guys. So we're saying now B intersection C complement. So C complement will be in this. Okay, so this is the C complement. Okay, so since this is and we can also have C complement there, but B is not reaching there, so we won't like pay attention to that. So what we are going to do is we'll shade here. This is where they intersect with B. Okay, so they will end at negative 5, right? So they're ending at negative 5. So you can see where they intersect with B, B is not close, so 5 is not what? Included. Okay, then we come now here, we say, what will be our chance? We can have this point here. But since they are saying I would have written, also I would have closed here where the intersects just. Okay. So now I want to do that because I have also A. Okay. So in A there, we are ranging to 6, right? There's 6 there. So you say 6 there like that. So these are what our set of values that we wanted. Okay, so let's go to the next question. So that's how you are supposed to approach this such type of question. That's how you need to approach them. Then express this one in the form of A over B. So what we need to do here is we have 1 there, okay? We have 1 there, okay? Plus root T. We have 1 there root T, 2 open bracket squared like that. Then we square this one. Once we square this one, it will be, we just say 1 square, that is 2 1. Then these 2 they'll add at some point. So you say 2 of these. Okay. Then from there, then you say this one again squared, you put it here. This is a quadratic squared, right? So you say that is just 2. Okay. So now this would be 3 plus root 2 like that. Okay. So you have seen this is in the form. So we are done. This is how we are supposed to do. In case you are confused here, we say 1 plus root 2, right? Again, 1 plus root 2. Okay, they are squared. This time that is 1. This time that is plus. It's plus the same thing, root 2. Okay, root 2 again. All right, this again times that is again plus root 2. Then this time that is just 2, which is this plus this is 1 plus this time plus this root 2 plus root 2, that will be 2 root 2. You add, there's 1 here, 1 is more like x plus x, which is 2x, then plus 2. This plus 1, that will be 3. So it will be 3 plus root 2 root 2. So you are done. That's how you're supposed to approach this one. Then coming to the one which is down, expressing the form of a over b, still the same case. So what do we do for this one? So what you are going to do for this one, we say just the same case as well. Now, in this case, all right, in this case we have root 2, all right, over 1 plus root 2, okay, squared. You remember this one is the same as this one, which is squared. So we are from finding the answer as 3 plus, okay, 3 plus 2 root 2. I won't even struggle. You can still expand this to give you the same thing. So I'll say this equation here or expression is root 2 on top there. Then we have 3 plus 2 root 2. So this is, I've just expanded this one. Then from there, what you are going to do there is we can now multiply by its conjugate. Okay, we can now multiply by its conjugate so that we can cancel. We can rationalize the denominator so that we bring this root because they want to be a numerator, something with a root. So now we'll say 2 root 2 there. Okay, then over here we have 3 plus 2 root 2. Okay, so then again we have 3 minus 2 root 2. Okay, then the same thing is 3 minus 2 root 2. Okay, okay, so this will multiply with everything on top there. Then down here is a difference of 2 squared because we can have the, so here it will be 3 squared. Okay, so have 3 squared, which is 9, then minus, okay, 4 squared, this is 4, then root 4. This time this is 2 again, right? So that will be 2. Guys, it's a difference of 2 squared. So we have a minus b squared, which can be written as, okay, we just square this. Then this is the form of a minus b, then a plus b. Hope we are clear here. So I've just picked this one, like this form, because this is the one I have there. Then I've just picked, I've squared, 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 and I'm getting this. Then this one I'll also multiply there. There to be root 2, then 3 there. Then minus. Okay, this again times that, it will be 2, all right, inside there. Okay, so this 2 times root 2 inside, that will be 2, right? So it will give us 2 just because it will cancel. All right, so what will remain, we are going to remain with, this will be now this is 4, so say 3 root 2 minus 4 over, down here this is 8. 8 minus 1 is just 1. All right, I mean 9 minus 1, that's just 1. So you leave it. So you say in that form that they have said, this form, you can write now negative 4, okay, plus 3 root 2 like that. So this is what we are supposed to write. So in that form of which they have specified, this form. Okay, so that is it about that one. Let's go to the next page. Okay, so the question express the following in the form of a over b. So we have 2.534, okay, like that. So I said, remember last time I said in the other video, say when you are solving this one, you say let x be equal to that number, right? So say 2, 5, 3, 4, like that. Okay, so make sure that the independent number which is not in the bar comes this one step. Again, the second step now, you say the whole which is in the bar come this side as well, then that is second, then you subtract the 2. So what you are going to do here, for me to bring this one, I'll multiply times 10 so that the point can come there. So I'll say this is 10x, you multiply throughout, that will be now 25.3 bar, like that. Okay, so from there now, this is my equation 1 because I've shifted the independent. All the independent should be on the left of the point. So now the second equation, I'll say I want this one to come here. There were a lot of 3 bars, just like that. So now I'll remain with the other bars. So I'll just want this at least to come this side. So that will be now, you multiply by 100. So if I multiply 1 by 100, that will be now 1000. X is equal to, so this 25 here, okay, will remain there, then we'll bring the 34 there, okay, then point again 34 because it was in the bar. Okay, so from there then you subtract now 1 from 2. So when you subtract, you have 1000x is equal to 2534.34. Okay, then from there we have 10x, which was our equation 1. Then we have 25.34 as well. Remember they were in the bar like that. This bar subtracted to be what? To be 0. Then this minus that is 990, right? So we are saying 990. So it will be 990. X is equal to, so when you subtract this 4 minus that, that will be now 14. So which will give us just okay, 4 minus 5, that is we put 1 there, that will be 14. 14 minus 5, that will be 9. Then that will be now 0. All right, then 25. Okay, 25, like that. So now you divide throughout by 990. Okay, I'm sure this is where I can end as for me. So you can still simplify if you want. You try 5, but I don't think there's a number that can go. Okay, I'm sure I should just end here before I make a mistake in my division. So that's how you are supposed to solve this one. Okay, hope that is clear. So that is how you are supposed to write that one. Then what about this one? We have 5 root 6. Try by all means to maintain what they wanted here. So these are just sides. Okay, 294. You need to know numbers that are factors. Like for here, we have 5 root 6. I don't have a number that I can multiply and can result into a root inside there. Just that those numbers that can make 6. So what I'll do, under 24, I can say I have 4, okay, times again root, still the same, they can be inside. 4 times that is 24, all right? Then plus here, what number can I use? I'm using 49 times 6. It will give you, the key should be this basic here. Try by all means to produce 6. So here I'll say I can have root 49, okay? Again, root 6. When you multiply, they'll give you this. Again, when you multiply, you get that. So that will be 5 root 6 minus this now will come out, right? That will be 4, right? Because root 4 is perfect. 4 is perfect. So to multiply, that will be negative 4. Then root 6 will remain there. Okay, plus here it's 7. So we'll have 7, then root 6 will remain there. Okay, hope that is clear. So from there now, it's more like x plus x plus x, you get. So it's more like 5x minus 4x, then plus, you get. So you can write this expression as, if I want, okay, no, so that you don't get confused, I'll say let root 6 be equal to x. So this will be x, then plus 7x, so that you don't get confused. Otherwise, you can add just like that. So now here it is what? Just x, then plus 7x, which is 8x. Remember, x is root 6, so it will be 8 root 6. You are done. That's how you are supposed to write this one. Okay, so let the operation let the star be a binary operation on the set of real numbers defined by a star b is equal to this one, and this is the order, by the way. Then determine whether the binary operation is commutative. So when something is commutative, okay, star a star b should be b star a. So I can test this one by using numbers. I can say I can choose n numbers, or even using the same variables still give me the same answer. All right, okay, let's do this. What I'm going to do here, I'll say, if I want, I can say uh, let a, okay, let a be equal to 2 and d be equal to 4, like that. Okay, so what I'm going to do here to test this one, for the first one, okay, I'll test this one, which is a star b. Okay, so this should be, okay, so I'm just replacing these values. Now a star b is already given there, so I'll say a, now they're saying is 2, so I'll say 2 open bracket, then our b is 4, okay, then minus open bracket, our a again is 2 minus 4 squared, which is 8 minus, this is what is inside is negative, right? So it's negative 2 squared, which is 4, right? Positive 4, positive 4 minus that will be 4. You get? So this is 4. Then this was a star b. What about b star a? Okay. B star a will be, we can see that you just change the expression. Wherever there's a, you put b. So it will be b a minus open bracket b minus a. Okay, squared. So let's go. B is what? We said b is 4. Then a is 2. Then minus open bracket. Our b is now what? 4 minus our a is 2, okay, squared, like that. So we can see now this will be 8 minus, this is inside this negative, which will be 4, which will still give us 4. So we can see that a star b is equal to b star a. So hence the operation is closed on the set of real numbers, or the binary operation is commutative. All right, okay, on the set of real numbers. So the other one, it says so what I'm going to do here is I'll say using the definition above this one. So we have been given an expression to say this is 3 star open bracket negative 1, okay, negative 1, okay, negative 1, then star 2, like that. So meaning that this is now our a, this is our b, this is the order which they gave us. All right, so what you are going to do here is will be, we'll write 3 star, okay, open bracket negative 1, then star 2, like that. Okay, so now the expression which they have given us this one, so we'll follow this order here. So I'll say a b minus, all right, a minus b squared. So we start at this point. We are solving this part which they have put in the brackets, the one which we respect first. So what we'll do is we are replacing, this is our a, this is our b. That's the meaning, because that's how they expressed it. So then I'll say where there is a, I'll put negative 1. So I'll say negative 1, open bracket, that is now 2, then minus, open bracket, our a is negative 1, then minus 2 there, then squared. So meaning that this will be negative 2. Okay. So this will be negative 2 minus, inside there we have negative 3, which will be squared. So this will be negative 2 minus 9, which will give us negative 11, right? So this is now negative 11 here. So meaning our next star operation will be 3 star negative 11, like that. Okay, so where this one will be our a, this will be now our b. So let's go. We are almost there, simplifying this. Okay, so now the operation that we have, they were 3, by the way. So we have reduced it to 2 according to what they had put in the brackets. So again, we also again reduce because we have come to the conclusion. So we'll say 3 star negative 11. This is now our operation, okay? It's just a matter of substituting now. A, B, all right, minus, open bracket, A minus B, then squared. Okay, so now our A is 3, okay? Then our B now is negative 11 minus, open bracket, our A is 3 minus B, which will be now, which will be now 11, okay? Because it was negative, then squared like that. Okay, so this will be negative 33, then minus, what is this? 3 plus 11, that will give you what? What is 3 plus 11? So you add that to give you 14. So 14 squared will give you what? So we have negative 3 there. Okay. So 14 squared, that will be, okay, you can just do this. Then you put 14 squared there. That will be 16, then plus that times that 8, which is 9, then 1. Okay, 196. So you say 196. Okay, so subtracting this one will give you 229. So we say negative 229. Okay, so that would be the answer for this one. So that's how you are supposed to solve this one. So this commutative form, it will be this. Okay, so if f of x is given as 2x minus 3 and g of x is equal to x plus 1 over 2, all right, x squared, find fog and state its domain. So what we are going to do is, we are saying find fog, meaning that the g of x will go into f of x. That's the meaning. So we'll bring f of x there. Okay, so our f of x is, let me just start from there. Our f of x is equal to minus 3, meaning that g of x is now being substituted inside. So I'll say wherever there's x, I'm putting g of x. So I'll say then there will be x plus 1 over 2 minus x. All right. So that's how I'm going to simplify this one. All right. So after simplifying this one, I'll say, I'm sure this one should be squared, if I'm not mistaken. Let me check properly. Should be squared. Okay, should be squared, this one. Okay. Okay, what I'm going to do here is, okay, suppose it's not a squared, then I'll say minus 3 like that. I can't just see properly if it is squared or not, but it should be squared. Okay, let's go just like this. Then here it will be 2x, you multiply throughout, then that will be plus 2, right, over 2 minus x like that, then minus 3. Okay, so from there, then what you need to do is, okay, what is common is 2 minus x, then 2x minus that will be 2x, all right, plus 2. Then here it's minus, right, minus 3. So this minus will multiply times everything. So have negative 3, open bracket, then we have 2 minus x like that, which will give us 2x plus 2 minus 6, then minus, which will be just plus 3x. Okay, remember there is 2 minus x there. Okay, then from there, then we can see that this and this is giving 5, right? I don't know if I'm not mistaken. So that should give us 5. All right. So that would be 5x. Okay. Then 5x minus this minus that will give us 4. Okay. Then we have 2 minus x like that. So to find the domain now, we are just getting what is down here. Okay. So you say what is down, the denominator not equal to 0. So we say 2 minus x should not be equal to 0. So meaning that if we solve x there, okay, if we solve x, that will go there, that will be positive 2 because the negative there will cancel. So meaning that x is a member of all real numbers, but x should not be equal to 2. So this is the domain that you are supposed to write in. Okay. So determine whether the function is even, odd, or neither. So what we are going to do is, if the function, by the way, you respect, so the function is given as y is equals to x squared minus 4 over x cubed. Okay. Since it is given like this, so what we need to do here is, since I have the highest power as odd, which is 3, I'll respect to solve first. I'll start with the odd proving part. So I'll say if it's now odd, you call to say if odd, okay, then f of negative x should be equal to the same function but multiplied by a negative. Okay, so let me insert f of negative that inside there. We'll see what will happen. This side I'll be doing both so that we see whether it will be equal or not. So this side I'm inserting negative x wherever there's x. So I'll say negative x squared here, then minus, all right, open bracket again, x to the power 3 there is equal to, I multiply the same function minus, okay, x squared minus 4, okay, then x to the power 3 like that. So what I'm going to do here is just x, right? Good. Then it will be just x squared, then minus 4 over negative x cubed. Okay. Then here I have negative, this negative, okay. So this negative to be x squared, then here to be plus 4, okay. Then here I have x to the power 3. I've just distributed this negative throughout, okay. So even here, if you can see here, okay, this negative will be for everything. So I'll start, allow me to start here, this one. So it's more like x squared divided by negative x cubed, then minus 4 divided by negative x cubed there, okay, which will give us x squared, okay, okay. So that will give us negative over x cubed, then here it will be positive 4 over x cubed. This can be written as, what is common is still the same thing. So you say x to the power cubed, then you write negative x squared plus 4, okay. You have seen that this is equal to this what we have just multiplied there, you remember? So this function was odd. I can't even go and prove even because it has already shown one character. So this function was odd, guys. It wasn't neither or what, it was odd. Okay, so now let's go and show that the function is one-to-one. So you need to know, they'll say injective, subjective, all those terms. So you need to know. In case they bring such a case, then you'll be okay. Okay, so what we need to do here is, for this one we are saying we have 3x plus 2 over x minus 1. So I want to show if this function is one-to-one. If the function is one-to-one, then you can produce such expression whereby is equals to 2 is equals to 2. This is what we want, okay? Or letter is equals to single letter. But in a situation whereby let's say a function is giving this, then it's not equal to function, okay? It's not equal to one-to-one. So what we are going to do here is, this function here, I'll solve it very fast. So same, we need to have two functions. The other one our name is as x1, or let this first function have the variable as 3a, okay, over a plus 2, then minus 1. Then the second one should be equal to, should also produce the same but different variables, okay, just like that. So you cross multiply there. So this time that, so that will be 3ab. Then the a times that will be 2a. Okay, again the same negative 1 times that will be negative 3b. Then negative 1 again times that will be negative 2 is equal to, again this b times 3, that will be 3ab. Then the same b times 2, that will be 2b. Then the same -1 times that will be -3a. Then again the same negative times 2, that will be negative 2. Okay, then from there we can group the like terms. We can see that if this 2 goes there, it will be positive, so this 2 and this 2 will go, right? So we'll have, again we have, okay, so I'll say 3ab plus 2a minus 3b is equals to 3ab, okay, plus 2b, okay, minus 3a. Have you seen? If what you are going to do here is, okay, then I've run out of space. Let me just lab this side. Okay, so we are simplifying this one. So what will happen is that we can see this one and this one, they are the same, a b a b. So this and this, and I'm not supposed to cancel like that. So we have a b, right? So this and this is going, all right. So we are remaining with 2a minus 3b, okay, 3b like that. Then is equals to negative 3a plus 2b, this one here. Okay, so now how do we simplify further this one? So we are saying, I don't know the mistake, but this function is supposed to come 1 to 1. So what I'm going to do here is I'll say, I'll just equate. We can see this one is equal to this. So this a here, all right. So I've made a mistake somewhere. They're supposed to be cancelling. Yeah, I've made a mistake somewhere. Okay, they need to be equal. This function is equal, so it need to give something. They are of the same power. That's when you can know that is the same thing. So this function is supposed to give at the end a is equals to b. All right, all right, all right. Okay, so what you are going to do here is still the same thing. Even at this point where I am, I'm not stuck completely. So what I'm going to do here, I'll say 2a, okay, is equal to 2b, okay. In terms of the variables, then I have 3a negative, 3b is equals to negative 3a. You can see that 3 goes there, so have a is equals to b at this point. Even here at this point, a is equals to, which shows that a function is 1 to 1. So that's how we are supposed to solve this one. So you explain, you give some quotation when you are writing such thing. We know that something like that. That's when the solving becomes interesting. Even a lecturer will be very happy. Okay, so we have done this one. Okay, we have remained with these ones. Okay. Okay, so now the question says, given that the equation has a distinct root. So when something has a distinct root, how do we do it? We say b squared minus 4ac should be greater than 0. Okay, equal roots, something like that. Know that. So for distinct should be this one. Then what do we do? So we have, then we are asked to find the possible values of R. So let's go. So if we say b squared minus 4ac should be greater than 0, our b there is what? 4. So that would be 16 minus 4. Our a is what? 1, right? Then our c, which is R, we don't have. Okay, so I'll say R then is equals to 0. See, they are saying find the possible values of what? R. So what I'll do is I'll say, you see, 16, all right, then minus 4R, then 0, like that. So that will go there. So it will be negative 4R, then greater than negative 16, by the way. So we divide throughout by negative 16. Okay, negative. Divide throughout by negative 1, throughout by negative. So the moment you divide throughout by negative, this one will change because it was representing something. So that will be 4R. Okay, then it will be 16. Okay, so what you are going to do here is we'll say now 4R, okay, is less than 16, like that. So divide throughout, that will be R is less than 4, like that. So this is the answer that you are supposed. These are the possible values of R. So you always put less than, let's say 3, 3, anything that is less than 4. Those were possible values of what? C, which is the R. Okay, so this was the equation, expression. So that's how you're supposed to solve this one. So the polynomial, okay, the question says the polynomial, this one is divided by this, okay, x minus 1, and leaves a remainder of 10. So it leaves a remainder of 10 when divided by what? By this. Okay. So what I'm going to do is for the first one here, meaning that x minus 1 is equals to 0. So x is equals to 1. So I'll press p of 1, then is equals to, you put wherever there's x, you put 1. So there on top there, that will be just 3, 1. Then minus, again to be just 2, plus again to be just p. So it will be just p1 is equal to, remember should be 0 if it's a factor. So it will be 3 minus plus p. Okay, good. So what you are going to do here is we'll say now we'll say by the way, I've left a certain number here. Q. I was leaving Q there. Q. Okay. So this will be P1 is equals to, this will be 1 plus P minus Q. Okay. Remember, should be 0 because it was supposed to be a factor. They haven't specified whether it was leaving a remainder or not. So meaning that P, okay, minus Q, I'll take this one to that side to be negative 1. Then I'll call this as equation 1. Okay. So now I'm coming again to the case where they have said when divided by this, it leaves a remainder. Okay. So for this one, I also solve this expression x plus 1, which is equals to 0, meaning that x is equals to what? Negative 1. So I'm testing this negative 1 now. Okay. So I'm testing this negative 1 now by saying P of negative 1 is equal to, you put negative 1 whenever, so here it's an odd, so it will produce negative 3. Then here it will be just the negative will be cancelled by the even power, so that will be just negative 2. Then here it will be negative P. Okay, then here it will be minus Q, like that. So here they are saying it is leaving a remainder of what? It is leaving a remainder of 10. So I'll put 10 as the remainder. Okay. Then minus, here it's what? Negative 5. Then P minus Q. Here when it comes there, that will be 15 is equals to what? Negative P minus Q. I can make P the subject of the formula. At this point, if I want from this equation, I'll say P is equal to negative 1 plus Q. So whatever there is P, I'll put that value. Okay. So negative open bracket P is now negative 1 plus Q. Okay, minus Q. Then I'll say 15 is equal to, this is now plus 1. Okay. So this time that is 1. Then this time that is negative Q. Then minus Q. So this one, it will come there. Then that will be 14 is equal to this time that will be negative 2Q. Divide by that will be Q is equals to what? 7. In fact, negative 7. So our Q is negative 7. So we can get one expression, whether this one, I like this one, which is already simplified, to prove also for P. So we have P from equation 1 minus Q is equals to negative 1. So now our Q is what? Negative 7. So I'll say P minus, okay, by the way, Q is negative, also Q is negative there, and also 7 was negative. So it will be minus 1. So this will be plus 7 is equals to negative 1. It will go there to be negative. So P will be negative 8. So these are the values that, the possible value of P and Q. Okay, so you can solve it like that. I've used simultaneous using substitution method because we had two equations. Okay. So then the other question says, solve the following equation. So solving this equation, you have 2x plus 1. Okay, root x is equals to 1. So what we do here is, we cross this one. I want this the complicated one to be simplified. So I'll say root 2x plus 1. Okay, then that will be 1 plus root x. So you Q this root by multiplying by 2. Okay, both sides. So here it will, when once you multiply times 2, that will be just 2x plus 1. Then is equals to this one, it will be, this is a quadratic. Okay, you need to have this for to know this form. This one is more like 1 squared, that will be 1. Then these two they will add, so you say 2 plus x, like that. Then this one again squared, that will be just plus x. You can expand, you see what will come out. I'm just doing it this fast. Okay, so we can see that 1 and 1 goes, right? Okay, then again x there, it will be just x here. Okay, because it will come and subtract this, and it will be just x is equals to 2 root x. Then from there I need to cancel. I don't want a root to have the value of x, so we square both sides. So when you square, also 2 will be squared there, so that will be x squared, also x will be squared. So that will be now x squared, that will be 4. Then x squared root, that will be just x, it will cancel. Okay, then by virtue of having 2 as the power, highest power, this is a quadratic. So I'll say x minus 4x is equals to 0. Then I'll factorize there. What is common is x. So I'll remain with x minus 4. Then is equals to 0. Okay. Then I'll say x is equals to 0, or x is equals to what? 4. So these are the value we can test. Let me test just one. Let me get 0 so there. So inside there I'll have 0 plus 1 minus um what is this? X. If I put 0 there, x, then okay, that will be just there. Inside there will be 1, then minus root 0. Root 0 is 0, so that will be root 1 again is 1, 1, then minus 0 should be equal to 1, and for sure 1 is equals to 1. Even 4, when you try 4, it will still give you the same product. Okay, so that's how you are supposed to solve that one. Then for this one, you need to know one thing here under inequalities. So what you do is you group the like terms, do not cross multiply. Okay, so if you cross multiply, that is the biggest error you will make. Okay, then this will be minus 2, then like that. So from there, then we'll see what is common is x minus 2, right? Then this, now this into that will be just the same thing, which is 2x minus 3. Then now this will multiply minus 2, open bracket, this what is we have here. Okay, so then we have x minus 2. Okay, this time that will be 2x minus 3 minus 2x. Okay, then plus 4, right? Then is less than greater than 0, like that. So meaning that this and this can go, you can see. Then negative 3 plus 4, that will be just 1, right? That will be just 1. Then we have x minus 2 should be greater than 0. So now we'll test this. We want numbers of x that will be giving 0. So what you do is you go on the test of signs. Okay, so the value here, we solve this one. You say x now minus 2 is equals to 0, which is x is equals to what? 2. So now we'll put 2 there. So I want to see this side or this side where x will be giving the greater values, that will be greater than 0. So here, this side here, okay, I can test 0 if I want. So if I put 0 here, I'll have a negative, right? Again, this side here, okay, I can put 3 there. Can test. If I put 3 there, by the way, it's minus. If I put 3 there, that will be positive, right? And we want numbers that are greater than 0. So meaning that this guy will be equal going this side. So the solution set would 2, because if we put 2 there, it will be 0. So I want to include it. That's the reason why I'm putting open. Then close, then positive, infinite. So those are the tables of values, or just ranges of value for x. Okay. Okay, so that is it about this one. Then let's go and do the other part as well. So we have expressed this one in the form of this one. So what you're going to do here is we'll say 1 minus imaginary line, which is the complex, then 2i, then 3, like that. Okay, so what do we do with this one? So they have given in form of numerator, so meaning that we are killing, our target is to kill what? The denominator. So the denominator will do the conjugate thing. So have 2i minus 3. Okay, the same 2i minus 3, which is 1. I've changed nothing. So here, down here is different of 2 squared. So I would say, I'll just get this one to say 2i squared minus 3 squared. Then here, this times this, that will be 2i. Then 1 times that, that will be negative 3. Then negative I times that, that will be, it is supposed to be negative because I times I again, it will be positive. So it will be positive 2. Then in the same negative I times that, that will be negative 3i. It will be positive because again we had negative there and also negative there. So now we can see that 3 minus that, that will be negative 1, right? Then this time plus this, that will be plus 5, plus 5i. Okay, then over this we have, that will be negative 4 minus, this is negative 9. Okay, so this will be now negative 1 plus 5i over, this is now 11, right? So from there, then we can say negative 1 over 11. Then again, by the way, it's negative, so it will be positive now. Then this one is now positive, so it will be negative 5i then over 11, like that. So this is the form that they wanted, where I is the root and also this one is just the constant number. So that's how we are supposed to solve this one. I've just done it in fast way, so you don't have to struggle when you see such to my simple questions. So for this one, when you have this one, I can say let b or any other variable be equal to 2 to the power x. Okay, so this one I can write it as 2. Okay, 2 to the power x, which x, this x can also be like that, 2 like that. So 2x is there, then minus 6 open bracket 2 to the power x minus 16 there. So we can write as 2 to the power x 2, okay, or which is 2x like that if you want, minus 6. They have already simplified at this point for the form, for the values of b. So what I'm going to do here is I'll say let b equals to this one. So I'll say this is now b squared minus 6. Wherever there's 2 to the power x, I'm saying is b, then minus 16. So we look at the numbers that are what? Product, when you add them, they give you negative 6, and when you multiply, they agree. So I'm sure those numbers we have b minus, I can write here 8b minus plus 2, yes, plus 2b, then minus 16. Okay, then it's equals to 0. So those numbers I can now, what is common here? Okay, so the expression is b squared minus 8b plus 2b minus 16 is equals to 0. So here, what is common here is b minus 8. Okay, what is common here is plus, okay, 2 open bracket, we have b then minus 8 is equals to 0. So meaning that b plus 2, then we have b minus 8 is equals to 0. So here it will be b is equals to negative 2, then b is equals to 8. So this will be discarded because we are doing it as exponential at the end. So we equate everything to power, to b to the power 2x, or just 2 to the power x, because that's the value of b. As I'm saying, this is discarded because it's negative. Okay, we can't express in the exponential form. So b, we said, is 2 to the power x, then it's equals to 8. So here will be 2 to the power x is equals to, again, this can be written as this, meaning that x is equals to what? 3. So that is it. But if you do this one, it will refuse. We say 2 to the power x is equals to negative 2. You see, this is not equal to this. So discarded. Okay, so that's how you were supposed to solve these questions I sent, though very few submitted the work, but anyway, like such thing, it will come in an exam. This one, want or not, and also this one is also a must, proving. Then also binary operation, rational functions, then this type also will come, and also this one will come. So just be geared. So that is it. Okay, thank you very much.